Hello again. Okay, so this lesson is linear transformations. So there's a little warm-up activity that typically I would do, but it's kind of hard to do virtually. So we're just gonna kind of dive into it. I'm actually gonna end with the Desmos sliders. So I do want to show you the activity. All right, so we're gonna look at what we call the linear parent function. So ladies and gentlemen, I cannot stress this enough. Knowing what a linear parent function is crucial, imperative, and vital to Algebra 1, like throughout the entire year. Not even just to like this lesson or unit, but for like the entire year. Like you want to know what parent functions are. So a parent function is the graph of the original function with no transformations. So when I say transformations, I mean no changes. No changes, no alterations, no substitutions, just exactly how it is. So the parent function in slope-intercept form, well, first off, we're going to go over slope-intercept form. So slope-intercept form, if you remember from the previous lesson, we have y equals mx plus b. So for your parent function, it is this value right here. So f of x equals x, or y equals x, which, oh, it's supposed to put right there. So it's y equals 1x plus 0, or just y equals x. So this is just the OG. It's the OG linear equation. Let's get rid of that. Okay. So if you notice, if you're looking right here, your slope is 1 with a y-intercept of 0. So it's also a direct variation, if you remember right. So I'm going to start by just graphing the parent function. So I'm going to start at 0 at the origin and go up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. So it's just constant up 1 over 1. All right, so I'm actually going to go the other way as well. So I'm going to go down 1, left 1, down 1, left 1, down 1, left 1, down 1, left 1. So as mentioned before, you only need 2 points in order to form the line, but just to give you some practice, because graphing is very important. Okay, so I'm going to extend and draw some arrows. So this is our linear parent function. So this is the original with literally no transformations. All right, so we're going to graph transformations that involve what we call a vertical shift. So we're looking more specifically at the b value. So over here, we have our mathematical notation. So if we have a b value that's equal to 0, so what our parent function has, it doesn't have a b value, or it does, but it's 0. So what this means is there is no vertical shift. All right, so if our b is positive, like if it's plus 5, plus 6, plus 9, plus 10, then that means it's going to be shift up. And whatever that number is. So shift up 7 units, 8 units, or whatever. So this is the notation that you would write whenever you're writing and listing out the actual transformations. So now after b value is negative, so if it's minus 4, minus 3, minus 20, minus 50, minus 20,495,206, doesn't matter. Whatever it is, instead of a shift up, now it's going to be a shift down. However many units. All right. So let's actually graph some of these. So I actually went ahead and color coded these as well so you can see what graph corresponds to which equation. All right, so now we have y equals x plus 3. So we have our parent function up here, which is the OG, and it's already graphed over here for us. So what I want to do is now I have y equals x plus 3. So what this means is I'm going to shift up 3 units. So that plus 3 means I'm going to go up 3 units. So I'm not changing the slope. Why is this off? Excuse me, my OCD. There we go. Okay, so we're going to shift up 3 units. Now here's the thing. I never once said that we're going to change the slope. I never once said we're doing anything else. I literally want to take this same exact equation, and here, let me show you exactly what I'm going to do. I'm literally going to take my scissor tool, go around my equation, copy, paste. So my equation is red. So I want the y-intercept to be at plus 3. So this is where my original is. So now I'm going to look at my y-axis. So I'm going to go up 3. So 1, 2, 3. So notice I didn't change a single other thing about my equation other than I just took it and I moved it up. That's all I did. So that's the red equation. So now in green, so now instead of up 3, now I want to go up 6. So what this is going to say is shift up 6 units. All right, so once again, I'm going to do the exact same thing. Paste. So I'm starting with my original. So at the parent function. So let's change it to green so we can see it. All right, so here's my original. Now I want to go up 6. So 1, 2, 3, 4, 5, 6. So if you notice, once again, I did not change the steepness. I didn't change anything about it except for I literally moved it up. I translated it up. All right. So now let's look at the purple. The best color ever. All right, so I'm gonna go back to this mode. All right, so now we have minus 3. So now instead of shifting up, now we're going to shift down. So this is going to be a shift down 3 units. Okay, so on my graph from the original, so I'm gonna change this to purple. All right, so here's my original, the parent function. So I'm gonna take the exact same function, the parent function, and I'm gonna move it down 3 units. So if you look on your y-axis, 1, 2, 3. There we go. So that's if I move it down 3 units. Okay, so notice I didn't change the steepness at all. It's literally the same exact line. All right, now over here, same idea. It's written in gold. So now instead of going down 3, now I want to go down 6. Did I just mess up my line? Okay. So shift down 6 units. There's a bug on me. Everything's fine. High key was about to scream, but everything's fine. I hate bugs. Okay. Where was I? All right. No. So original function, change it to gold. All right. So, no, start at my original function, the parent function. Now I want to shift down 6 units. So 1, 2, 3, 4, 5, and 6. There we go. So notice we didn't change the steepness of any of these lines. They're all just translated, they're moved. Okay, so what I'm going to do now is I want to kind of clean it up a little bit. It's just my OCD. Okay, I'm going to redraw those arrows. Oh no, we cannot have that. There we go. A red arrow, a purple arrow, and a gold arrow. There we go, much better. Okay, so that is vertical shifts. So you have to actually write out shift up or shift down. You cannot just say move up or move down. Like, you have to use the correct terminology and the correct verbiage. Okay, so now we're gonna move on to this next part. So this is what we call vertical stretch and shrink. So just one thing to note, if you ever see shrink, I don't know why this is still on gold. There we go. So if you ever see shrink, this is also another way of saying compression. So you may see shrink, you may see compression. They're synonymous. They mean the same thing in math, at least. All right. So once again, we're going to start with our parent function. So our OG, it's already matched, not matched, it's already graphed. English is really hard. So I'm going to do the same idea over here. So I actually want to write out the transformation that's occurring. So they're color-coded and everything. All right, so here, now we're changing the slopes. So we're going to change the steepness. But in this case, our B value is still staying the same. We're not going to be vertically shifting it up or down. We're keeping it exactly where it is. We're only changing the steepness. So over here, this, because our, actually backtrack, you need to go over here first. Okay, so if your M value is equal to 1, so this is what's in your parent function. So this would be no stretch or shrink. So if your M value is 1, if your slope is 1, then there's just no change. However, down here, if your M value is bigger than 1, that means we are going to have a vertical stretch. And yes, there is such thing as a horizontal stretch, but we're not going to worry about that. We're going to let Algebra 2 worry about that. All right, so now if your M value is less than 1 but bigger than 0, so this is what we call a vertical shrink. So shrink or compression. It's the same idea. So the thing here with the vertical shrink, so numbers that you could see here are like 1/2, 1/5, 2/3, 4/5. So they're fractions that are less than 1, but they're still positive. So any number that's less than 1, but it's still positive, that's going to be a vertical shrink. Now you have to be careful because not all fractions are going to be a vertical shrink. So if you have a fraction such as like 5/4, well, that's bigger than 1, so that actually falls under stretch. So more examples of stretches are if you have a slope of like 5 or 3 or 10, or even like 3/2 or 6/5. Like just any number bigger than 1, that is going to be a stretch. But if it's less than 1 but bigger than 0, that's a shrink. All right, so if it's negative, we're actually going to look at that on the next page. All right, so over here, now we have y equals 3x. So because their M value here is bigger than 1, this is what we call a vertical stretch. So this is a vertical stretch of 3. So it changes the slope. So instead of a slope being 1/1, now we're going to have a slope of 3/1. So we're still starting at the origin, but now I want to go up 3 and right 1. So 1, 2, 3, and right 1. So notice how it's already steeper. So 1, 2, 3 over 1. 1, 2, 3 over 1. All right, so I'm gonna go ahead and draw my line. So it's still passing through the origin. Now I'm gonna extend. All right. So now we're at a steeper line. So now I'm gonna look at the next one in green. So y equals 6x. So here, 6 is still bigger than 1. So what this means is we have a vertical stretch. So I'm actually writing out exactly what you would write when you have to list out the transformations, because I'm going to give you an equation and you have to tell me what are the different transformations. All right, so once again, start at the origin, and now we're going to go up 6. So 1, 2, 3, 4, 5, 6 over 1. Can't go up another 6, so I'm actually going to go the other way. 1, 2, 3, 4, 5, 6 over 1. All right. So I'm going to draw and extend my line. So as you see here, the line is getting steeper and steeper. So it's going to keep getting more and more vertical. So that's how you know it's being stretched. It's getting more vertically, more vertical. English is hard. All right, so now over here in purple, now we have 1/3. So in this case, our slope is going to be 1/3, which means it's less than 1. So this is a vertical shrink. So a vertical shrink of 1/3. So you have an option here of, sun's in the way. So you have an option of, you could say a vertical compression, or you could say a vertical shrink. It really doesn't matter. It's the same thing. I will say a shrink is fewer letters. So if you're lazy like me, you will go with the one that has the fewer letters. All right, so now we have a rise of 1, and we're going to run 3. So start at 0. So up 1, and then right 3. So 1, 2, 3. Oh, I probably should not have done that. There we go. Trying not to erase the whole line. There's the next point, and there's the next point. All right, so there's the arrows. So now this shrink, this is actually what we call getting flatter. So a stretch is actually getting steeper, whereas a shrink is going to get what we call flatter. So there's actually a good amount of vocab in this lesson. Oh, son, how dare you. So really being familiar with the vocab is really half the battle in this lesson. All right, so now last but not least over here, so now we have 1/6. So this, once again, is a vertical shrink of 1/6. All right, so up 1 and right 6, starting at the origin. So here's the next point right here. So up 1, 1, 2, 3, 4, 5, 6. All right, so I need to go the other way. So 1, 2, 3, 4, 5, 6, and then down 1. So there's the other point. Okay, so press and hold, now extend. Boom, boom. So now these are getting flatter. All right, so now we can actually do another transformation. So on the next page, now we're going to look at reflections. That's not a highlighter. That is a highlighter. What am I doing? So we're looking at what we call reflections. Okay. So once again, parent function, graphed, done. All right, so over here, looking at red. So we have this negative in front of the slope. So what that negative means is this is going to be a reflection over the x-axis. So that would be the actual transformation that you write out. So in this case, over here in red, now we have a slope of -1 as opposed to a slope of +1. So what this means is this has a reflection over the x-axis. So I'm still starting at 0 for my y-intercept, but now I'm going to go down 1, right 1. So down 1, right 1, down 1, right 1, down 1, right 1. So that's the path I'm going to follow. So I'm going to go ahead and draw my line. Try to. Hello? Oh my gosh. How dare you? There we go. Close enough. All right. So draw my arrows. So that is the reflection over the x-axis. So the only change here is that we have a negative slope now. All right. So now over here in green. So this is the kind of tricky part. So you have to think of the negative and the 3 as two separate transformations. So that negative is a transformation in itself. So that is a reflection over the x-axis. And then the 3 tells us that that is a vertical stretch. So we're actually bringing that back from the other one. So these are all actually going to have more than one transformation. So the negative in itself is one transformation. So the negative and the 1/3, those are two transformations. The negative and the 3/4, those are two totally separate transformations. All right, so now if I want to graph y equals -3x, we still have a b value of 0. So now I want to go down 3, right 1. So 1, 2, 3, and right 1. 1, 2, 3, right 1. 1, 2, 3, right 1. All right, so now I can draw my line. It's gonna bother me if I don't extend it. There we go. So now it's getting steeper, but it's also been reflected. All right, so now looking over here in purple, so now we have the reflection and we have that 1/3. So the negative tells us this is going to be a reflection. And the 1/3 is going to tell us it's a vertical shrink because it's less than 1. So also notice how whenever I'm saying vertical stretch or shrink, I'm being very explicit in the number and the factor that it's being changed by. I'm not just saying vertical stretch, vertical shrink, or whatever. I'm saying vertical stretch of 3, vertical shrink of 1/3. You're being explicit when you are referring to the transformation. So now in this case, once again, starting at 0 for your y-intercept, and then you're going to go down 1, right 3. So starting at 0, down 1, right 3. And so graph and extend with arrows. So now in this case, we're getting flatter. All right, and last but not least, so the negative itself right here, that is a reflection. It's a reflection over the x-axis. All right, and 3/4 is less than 1, which means this is a vertical shrink. So vertical shrink of 3/4. So now I'm going to start at 0 once again. down 3, right 4. So 1, 2, 3, 1, 2, 3, 4. So right there, put that point back. Nope, still gonna go away. All right, then down again. All right, so I'm gonna draw a line, connect those points. Try to. And there we go. Okay. So these are all the different types of linear transformations that you could potentially have. So notice how we have a maximum number of transformations. So a linear function can have at most, drum roll, this is super important, drum roll, can have at most 3. So 3 transformations is the absolute maximum number of transformations that you can have in a linear equation. So to give you guys a break from my terrible handwriting, I'm actually going to type these out. So I actually suggest typing these problems out, but it's up to you. All right. So for these actual practice, hello, what am I freaking? There we go. So for these practice problems, you want to actually describe the following transformations of the parent function. So remember, you're starting with the parent function and describing the changes. So if I look here, I have y equals x plus 2. Well, my original parent function is just y equals x. So that plus 2 right here, that is the big change. So because it's plus 2, that's a change in my b value. So what that means is this is going to be a shift up 2 units. And that's all that one's looking for. So over here, now we have y equals x minus 8. So in this one, our change here is that negative 8. So this is a shift down 8 units. So be very explicit and match exactly how I'm writing it. You have to say shift up or shift down. You cannot just say move up, move down, move left, right, whatever. So speaking of, there are horizontal transformations, but we're not going to worry about those because we actually take care of horizontal transformations when we do our vertical transformations. All right, so here we have f of x equals 4x. So notice how we didn't move it up or down with a b value, but we do have an m value of 4. So because that's bigger than 1, this is a vertical stretch of 4. That's 4. That's 4. So far in these equations, we only have one transformation, but we're going to get problems that have up to 3 different transformations. So now looking at number 4, we have 2 distinct transformations. So one of them is we have a negative, and then our other one is that we have this minus 5 right here. So in this case, we have 2 different transformations. So that first one that's highlighted in yellow, the negative with our slope, that means a reflection over the x-axis. And then the negative 5 over there, that's a b value, so that means a shift down 5 units. All right, number 5. So we have negative, and we have this 4/3 here. So both of those are transformations. So that negative is a reflection over the x-axis. And then the 4/3, it's bigger than 1, so this is a vertical stretch of 4 divided by, nope, I'll just actually write it. Okay. That's actually terrible. Close enough. So you can probably get away with typing the words, but you may have to write in the numbers, which is okay. All right, over here, number 6. Hello, there we go. All right, so we have several transformations here. So we have the negative, we have the 3/4, and we have plus 7. So we have 3 distinct transformations here. All right, so that negative is a reflection over the x-axis. So that 3/4, it's less than 1. So this is a vertical shrink of 3/4. I'll write in. Plus F. All right, and last but not least, that +7, which means shift up 7 units. So remember, be very explicit in how you write it. Your notation and how you write these things needs to match mine exactly. It needs to precisely match mine. All right, so just to kind of change up the notation a little bit, which you could potentially see on the STAR exam. So we don't typically use this notation, but it has been seen on the STAR exam, so we're gonna cover it just in case. So it's really similar to this up here. So we want to describe the following transformations of the parent function. However, f of x represents the parent function. So if I have f of x plus 2, this is the same thing as writing x plus 2. So in this case, because of the plus 2, this is a shift up 2 units. So just imagine the f of x as just an x value. So over here, now we have f of x minus 1. So it's just shift down 1. Shift down 1 unit. So now we have 3 in front of the f of x. So now that's the same as saying y equals 3x. So this is a vertical stretch of 3. All right, over here, number 10. So we have our two transformations. We have the 1/3 that's out in the front that impacts our slope, and then we have the plus 2, which impacts our b value. So in this case, the 1/3 is less than 1, so this is a vertical shrink of 1/3. Then over there, we have that plus 2, so that means this is going to be a shift up 2 units. All right, number 11. So now we have that negative out in the front. So that negative for our slope, this is only going to be a reflection across the x-axis. So that's the only transformation that's in that one. All right, so this one is going to encapsulate all 3 transformations that we could potentially see. So we have the negative, the 5/4, and we have a negative 9. So the negative, so that is a reflection over the x-axis. The 5/4, that's bigger than 1, so that is a vertical stretch of 5/4. And last but not least, then we have a shift down 9 units.